So this lab, we're going to use the MMC Python script to solve a couple of queuing systems. And if you're not familiar with the MMC Python script, there's another video module that you should watch that describes its use. In problem 1 of the lab, you're simply going to use the MMC script to complete the following table. So I have 5 single server queuing systems with a variety of arrival rates, service rates, and numbers of server, and you're simply going to execute the MMC Python script for the individual values and then record the result. So for example, we have the 62, the arrival rate of 62, the service rate of 35, and 2 servers. Simply do MMC Python. I can't even remember those numbers this long. 62, 35, 2, and then record. Oops, didn't mean to do that. And then record the results in the table. We can also use the Python function from within the interpreter. So if we do Python and then import MMC, and then we could do MMC, and then we have the 62, 35, 2, and we can execute that way also. And so again, if you're not familiar with the Python script, you should watch the video module on using the script. So after executing or solving the 5 individual systems, problem 2 involves developing a Python script that imports and uses the functions to solve all 5 queuing systems simultaneously, and then creates a list of dictionaries to store the results. To get started with problem 2, let's develop the pseudocode for the function that we're going to develop. And so essentially we have a set of problems, and let's describe the problems, or let's develop the data structure, and just assume that we're going to have a list here of the input parameters. So lambda mu c, so on, lambda mu c. And so we're going to assume that we have, oops, let's make sure this is a bracket here, not a parenthesis. Ooh, that's not what I meant to do. Right? Make sure that we have a list of lists. And so these are the individual problems. In our case, those values would be the 10, 11, 1, the 3, 1.23, 62, 35, 2, and so on. And so those would be the individual values. And so our data structure that we've developed for describing our problems simply includes 5 individual lists. Then we're going to have a solution. And the problem specifies that we want to have a list of dictionaries, so we'll just create an empty list, and then we simply execute the MMC function for each problem in our problems list. So in other words, we're going to do something like for prob in problems. The solution is equal to MMC prob 0, prob 1, and prob 2. And so we can see that prob 0 is the arrival rate, prob 1 is the service rate, and prob 2, in other words, element 2 of the list, is the number of servers. And then we simply append this solution to our list. Solutions, append, solution. There we go. And if we want, we can show the solution. So show solution. And then in the end, we will just print all of the solutions. And so we can see what we've done is we have a list of lists where each element of our list is a problem. And a problem is defined as the arrival rate, the service rate, and the number of servers. We then create an empty list to store our results, and then we execute the MMC function, which returns a dictionary. So each SOL value is a dictionary. We append that onto our list, and then we show for the user. And that's basically all there is to it. So alternatively, rather than using the list iterator here, I could also use the index. So instead of these 2 lines, I could also use for j in range length problems. And so in this case, J is now an index into the problems list. Now I would just have SOL is equal to MMC of problems J 0, problems J 1, and problems J 2. And so this type of loop will give me the exact same results. And in this case, we know what the individual index is. And so that might be useful, for example, if I want to use the optional argument for the show function, show SOL, and say, oops, let's make this a string, format J, for example. And so the optional argument for the show function lets you specify the title for the solution. So for example, if I do show MMC 6235.2, oops, MMC show, and then MMC, then we can use the results right here, J, and that will be the title. So the optional argument just lets us title that. And so if I use this alternative function, I can make a nice format that shows which problem I'm doing. But of course, either one of these will work, and they're equally good. And note again that we are using two functions from the MMC. We're using MMC and show, and both of those functions are described in the video describing that the Python module itself. And so that's it for the lab. Again, two problems. One is just using the Python script, and then problem 2 is using the functions and developing your own script to solve multiple problems.